Alright guys, we're going to be doing the second friction problem on the back. Let's look at what we need to do here. Okay, so one thing they're asking us for is this mu. Well, mu, there really is only one equation that involves mu, and it's this guy. It is force of friction is equal to mu times normal force. And remember, mu kind of is a mathematical indication of how rough two surfaces are going to rub together. So a higher mu means they're going to rub more, a lower mu means they're going to rub less. So we can rearrange that so that we say, okay, mu is equal to the force of friction divided by the normal force. Well, right now we have the normal force, it's right here, but we don't have the force of friction, so we're a little bit stuck. We have to go find it first. So let's look at the actual problem, okay? These two forces, the 12 up and the 12 down, are equal and opposite, so they're basically going to cancel each other out. So they're not going to influence the net force. All that's left right now is the force of friction. That's the only thing that's really going to accelerate this. So what can we do with that? Well, let's remember that net force is equal to mass times the acceleration. They gave us the acceleration. We don't know the mass. If we can find the mass, we can get that net force, which would be equal to the force of friction, and then we can stick that in and get the mu. Whew, that's a lot of ifs there. Okay, so the only thing we have left that we really kind of need to find is that mass. Okay, how could we do that? Well, I want you to memorize in your head, if you know force of gravity on Earth, then you can find mass. And vice versa. If you know the mass, you can find the force of gravity. And the equation we use for that is Fg is equal to mg. They gave us the force of gravity, it's 12. We're looking for the mass, and g on Earth is always 9.8. All right, we do some handy dandy math. We divide by 9.8. And we find that the mass of this block is equal to 1.22 kilograms. Okay, so now that lets us go all the way back over here, and we can now find our net force. F net equals mass, which is 1.22, times the acceleration. They gave us the acceleration, it's 5, and throw that in our calculator. 6.1, so 6.1 newtons. All right, now again, the reason that this is equal to your force of friction is because these other two forces are equal and opposite, so they canceled out. So it's like these guys aren't really there. This is the only thing that can really influence that net force. So this has to be 6.1 newtons. Okay, so now we're nearly done. We can go all the way back up to this equation here. Okay. So mu was equal to force of friction divided by the normal force. So the force of friction was 6.1 divided by our normal force, which was 12, and we get a mu of, hang on, throw out my calculator, 0.51, and there are no units on that. You may remember that from your notes. Okay guys, that's a pretty long, complicated problem. I hope this will help you with the other ones. Have a nice day.